Hi, my name is Kevin Nguyen. I am a product line manager for Advanced Consumer Power for the Battery and Consumer Power business unit here at ADI. Today I'll be introducing our SIMO PMIC to you guys. Our SIMO PMIC basically stands for Single Inductor Multiple Output. Generally speaking, whenever you have regulated output, you need a single inductor for every output. In this case, we're able to have 3 regulating buck boost outputs for a single inductor. It's some pretty cool black magic, if you ask me. With this SIMO PMIC, we're actually able to charge devices 4 times as fast as a traditional linear charger. So, in the consumer space, we always want to charge our devices as fast as possible. We don't want to have that much downtime. We want to have enough playtime, basically, right? Let's say you can imagine you have a meeting coming up in 5 minutes. You open up your hearables, your wearables, and you see that, you only have 5 minutes left of charge, and you need to charge this as fast as possible so you can take your meeting in the next 30 minutes. Well, with our SIMO PMIC, you're able to do just that, all right? So you can charge as fast as possible with this SIMO PMIC in the smallest form factor, because also in the consumer space, we don't have that much space to work with. We only have tiny spaces to fit a lot of these converters so that, you can charge efficiently while also retaining a small solution size. So with this demo, I'm showing you a side-by-side comparison. So the A earbud is our SIMO PMIC solution, and we're going to compare it against the traditional linear charger solution, which is the earbud B on the bottom. Okay, on the screen, you'll actually be able to see a readout of the charging current. So once I press the 2 buttons on the top and bottom, they're going to start charging the earbuds simultaneously at full speed. So you're going to see 275 milliamps current readout on the top and the bottom at the beginning. But what you'll notice when I turn on this thermal camera is that the temperature of the linear charger increases dramatically faster when compared to the switching charger. So what you'll also notice is that there's this JETA threshold temperature that you can set. It actually prevents the charger from charging faster. Okay, so once your charger hits this JETA threshold, it actually has to limit the current at which you're charging your device. But in our case, with our SIMO PMIC, we're allowed to charge this device at full speed, the 275 milliamps for the entire duration, whereas the competitive option, the traditional linear charger on the bottom, can only charge at about 76 milliamps when it reaches this JETA threshold. So this is why we claim that our device can charge devices similar to these wearables, hearables, 4 times as fast than the leading solution. So when it comes to a typical TWS solution, there's usually a linear charger in the cradle and also a linear charger in every single earbud, so both earbuds. Also, there's an additional boost converter inside the cradle itself so that there's enough headroom for these linear chargers to actually function in the earbuds. But with our solution, we do away with that whole entire boost converter. There's no need for that because there's automatic headroom control in our SIMO PMIC. So our SIMO PMIC has integrated automatic headroom control, integrated switching charger, and an additional 3 regulating buck boost outputs all in a single package. So ultimately, the solution size is significantly smaller than the leading competitors. So also, if you take a look at the board itself, this is the solution size that we typically have for the additional boost converter that's no longer needed for our device. So our solution is ultimately much smaller, much more efficient, better power dissipation, lower heat dissipation, and allows you to charge your device faster than the leading competition.